Okay, y'all, I've taken the Bert and Ernie scores and dropped them into an Excel spreadsheet. That'll give us some practice with Excel, but also make the computations quicker. I'd like to also apologize before we move on. This is an experiment I do in my class, which is great with a room full of people to kind of bounce ideas off of. So I'm going to give you what students usually say when I give them this problem. This is one of the few problems in my teaching career I've actually used this exact problem for over 20 years because it works so well. So this is the first time I've done it not in a live setting. So I'm going to kind of give you what students have given me over the years for this, and I just love the answers. So what most people do is they start by calculating the stuff we've just talked about, like an average, for example. So what I'm going to do is I'm just going to add down here, I'm going to spell it right too, average. And I'm going to bold and underline it because that's me. And I'm going to use Excel to calculate the average of each of these guys. I'm going to go equals average, and then I'm going to select all the data in Ernie's. And he's got an average of 81, which means if we took all of his test scores and spread out the points so that every one of his tests had the same number of points, they would equal 81. So for example, the 83 would take 2 of its points and give those to the 79. That would mean they would both have 81. And the 82 would take 1 of its points and give it to the 80, and they would both have 81. So that's your average of 81. And we've talked about that before. That's what the average is actually doing. It's spreading the points out. How about Bert? Well, I can just grab, what's nice about Excel is I can just grab this and pull it over. And Bert also has an average of 81. So you can do the exact same kind of shuck and jive and shuffle. You can take some of those 100 points and take 19 of them away and disperse them throughout the rest. As I'm kind of showing you right here, this is just one way to do it. So they have the same average. Well, that's interesting. They have the exact same average. So on average, they're the same. All right, that's kind of fun. Let's look at the medians. And I know with 5 data points, it's not that hard to spot the median, but you know, this is as much about practicing using Excel as anything. So I'm going to find the median of these 5 numbers. And for Ernie, it's 81, same median as the average. And for Bert, it looks like it's going to be 82 based on what I'm looking at. Yep, it's 82. So Bert has a slightly higher median, but again, still kind of in the same ballpark. All right, and the last one we talked about last time was mode. And I know this data doesn't have a mode, but I want you to make sure that you see what Excel actually does when you don't have a mode. It returns that, not applicable. And so it gives you a little fun little error message. So neither Ernie nor Bert have a mode. So when I look at this data, with the exception of mode, maybe I'll delete the mode because they don't have one. But when I look at the average of the median, which are the 2 main measures we've looked at so far, Bert and Ernie look exactly the same. But they're not the same, right? I mean, yeah, on average or on median, they're the same. But there's definitely something different about each of these 2 students. When I run this experiment in class, what my own students often say is, Ernie is more consistent than Bert, or Bert is more inconsistent than Ernie. And that's why we are talking today about measures of variability in data. Not so much how data is the same, but how it varies. Let's dive in.